Hello dear viewers, a very warm welcome to our channel. It's very good to have you here. In this video we are going to have a look at the cooling fan. The internal combustion engine creates a tremendous amount of heat. When there is internal combustion taking place inside the cylinders, there is a tremendous amount of heat. While the radiator, this radiator is responsible for dispersing this heat, it needs airflow through these fins. These fins, there has to be airflow through the radiator in order to cool efficiently. As you can see, the profile of the shape, the profile of the blade, the profile is there to suck air. Now, when this is turning in this fashion, for example, when it is turning in a clockwise direction like so, wind will be blown. Wind will be blown from this radiator side into the engine. So this is how the blades are configured. On stationary engines, however, in stationary engines like generators, it can blow air from in to out. But for cars, it is blowing air from front back into the engine, because when the vehicle is moving forward, that wind blow over the car will cool, and if the engine is kept stationary at a stoplight, fan has to work actively in order to remove heat from the radiator. At low speed, for example, when you're stuck in traffic, idling through the drive slowly, there is a little to no natural airflow. So there is where the cooling fan is very critical. It pulls air. Now when it is rotated like this, for example, this engine is running in a clockwise direction. As you can see, the profile of the blade of the fan, it is pulling air into the engine. For vehicle engines like this, usually wind will be blown into the engine. It will pass through the radiator, dissipating heat. So this is the profile of the fan. When it is rotating, it will pull air, and that will make sure that heat is dissipated. For stationary engines like generators, compressors, all stationary engines, however, it can sometimes blow air away from the engine. If it is a stationary engine, the direction of blow will be reversed, but for engines that are installed on vehicles, it usually pulls air into the engine. So this is how the cooling fan operates. It pulls or push air through the radiator to actively remove heat. Heat has to be dissipated from the radiator. This will prevent engine from overheating. When we talk about the different types of radiator fans, there are basically two types. There is a mechanical type. This is a mechanical type. It sometimes have clutch, sometimes it doesn't have a clutch. This is a mechanical type. It is bolted directly to the engine water pump or to the water pump pulley, and then it is driven by belt. Belt will be installed on here, and it will be driven by belt. So this is a mechanical type. There are sometimes engines with a fan clutch. Fan clutch is like this type of fan clutch. This is a key component. It is a thermostatic fan clutch. It has a viscous fluid in it, and it sometimes engages and disengages. For example, it disengages at low temperature. When engine temperature is low, it will disengage. So there is no need of using the entire efficiency of the fan. It will disengage. When the engine is cold, or if the engine is running at high RPM, when natural airflow is sufficient enough, the clutch will slip, allowing the fan to spin slowly, saving engine power and reduce noise. But when the engine temperature increases, however, this clutch will lock up, and that will lock up and make the fan spin at nearly the same speed as the engine, pulling maximum air into the radiator as well. This is a very simple design, robust and powerful design, but it will constantly drain engine power. That is the main disadvantage. It constantly drains engine power because it is constantly driven. It sometimes constantly drains engine power. A small amount of engine horsepower is going to be spent in order to spin this fan. It's like a parasitic loss, so that can be noisy and is less efficient than electric fans. Now the other types are electric fans. As you can see, this is an electric driven. There is an electric motor wide here, so it is driven electrically, and it is a powerful electric motor is used in order to spin the fan blade. Here we have for this particular engine, it is a 12-volt operated powerful electric motor. It is mounted directly on the radiator, and it is controlled by the engine control unit. If the engine doesn't have an electronic control unit, it is simply controlled by a temperature switch right there. If the temperature switch says it is now time for cooling, it will turn on the fan. But if the temperature is low and this one opens the circuit, the fan will not be spinning. So it will be turned on and off depending on the temperature. It only turns on when it is needed. A temperature sensor will tell the computer when to turn it on and when to turn it off. So this is a very simple configuration when it comes to electric fan. This is fuel efficient, only runs when needed. That makes it fuel efficient. That will be turned on only when temperature exceeds a certain value. So it will not be continuously draining the car battery. This makes it energy saving. And if it is controlled by the electronic control unit, it has a precise control as well. On some engines, it can even be driven at variable speed as well. It can be mounted anywhere. That is the other thing that makes it very sweet. It can be mounted anywhere. For example, as you can see here, the engine is right here. The engine is right here. Radiator is mounted separate place. So it can be mounted anywhere. Flexibility is there. And it can run after the engine is shut down as well. Some systems will run the fan for a short time after the engine is turned off to cool the hot engine. So that is a cool down cycle that can be very, very much useful, especially if you have been driving for a long period. The engine has to cool down, and that is done by keeping the fan running even after the engine is turned off. Now when we look at some of the key components of this electric fan, there is a fan motor right here. We have the fan motor. It is an electric motor that spins the blades. Right here we have the blades, and the fan blades are usually made up of plastic. Sometimes they are getting constructed from metal as well, and the blades are designed to move air efficiently. The profile is designed so they have an inclined profile. As you can see, there is an inclined profile. Here it comes out, there it goes back. So there is a profile that will allow to suck air through the radiator as well. It will help to move air efficiently and quietly. And as you can see, there are shrouds. Shrouds are there. The shrouds are basically a plastic housing that direct air flow through the radiator. So it will tend to concentrate the wind that is going to be blown by the fan blade. That is the duty of the shroud. A fan without a shroud is much less effective. So shroud will concentrate the wind that is generated by the fan blades. And as you can see, there is a temperature sensor or a switch right there. That is a very major and critical component there that triggers, that tells the system to turn on. That will turn on the system and turn off the system depending on the coolant temperature. And in some cases, this motor is usually controlled by a relay, a switch that handles the high current required by the fan motor. It is activated by low current signal generated either by the switch or by the engine control unit. A faulty relay is very common failure for electric fan type configurations. Fuse and wirings are also there in order to supply electricity to the electric fan. Now let's talk about some of the symptoms of a failing cooling fan. If there is a problem with the cooling fan, there are always symptoms. Well, the first symptom is engine overheating, especially at low speed. The most obvious symptom is when engines start to overheat, especially at low speed. That is the most obvious symptom of a failing fan. The temperature gauge shoots up in traffic but goes back to normal once the vehicle starts and set into motion. If it comes down, but if it comes higher when the vehicle is stopped at a traffic light, that is basically an indication of a failing fan. Usually the mechanicals, once they don't fail, most common failures are usually related to the electric type cooling fan configuration. When there is a problem with the wiring, when there is a problem with this wiring, when there is a problem with this temperature switch, right there is a temperature switch. When there is a problem with the temperature switch or when there is a problem with the wiring, this is the most common type of failure that happens on this type of fans, and sometimes the fan relay might go off as well. And the other symptoms that indicates a failing fan is when the air conditioning system is not working properly. If it is either boiling or warming at idle, the air compressor condenser in front of the radiator needs airflow to work properly. So If the fan is not running, then the air conditioning system will overpressurize and shut off to protect itself. That is also another indication of a non-functional fan. Loud or unusual noise, loud noise, roaring noise, grinding or clicking noise, all this can be an indication of a trouble as well. Loud or unusual noise, it could be caused by failure of this mechanical fan. If the mechanical fans fail, if these mechanical components fail, they will cause noise to be generated. A seized fan clutch or a broken blade can cause noise. And if it is an electric type, worn out motor bearing or blade hitting the shroud or debris in the fan circuits, that all can generate loud noise. And if fan doesn't turn on, it could be caused by electrical problem associated with the relay, or it could be associated to the motor itself. Always extremely careful, cautious around fans. Never touch it while the engine is running. Touching a rotating fan is very dangerous. And start by checking the basics. Is the engine really hot enough so that it can trigger the electric fan? Turn the AC to the maximum. On almost all cars, this should immediately trigger the cooling fan, regardless of engine temperature. If the fan runs, the motor and basic circuits are good, and the problem is likely the temperature sensor switch. And check for any fuses or relays that are bringing power to the electric fan. Listen for operation of the fan relay, and if you suspect the relay is in trouble, you can always directly power the electric fan, directly connect it. And if you are comfortable with the multimeter and basic tools, you can apply 12 volts directly to the fan motor connection. And then if the fan spins, the motor is good, and the problem is in the wiring, relay or sensor. If it doesn't spin, then the motor is likely dead. And when it comes to replacement cost varies widely depending on the model. An electric fan assembly can range from somewhere around $150 to $600 depending on the type and model for the part alone. And labor is very cheap. You can get it for $50 or $200. And replacing a fan can be a moderate DIY job. You can do it by yourself. Often requires draining some coolant and removing other components for access, and always disconnect the battery whenever you are working on electric fans. There is no regular maintenance for fan itself, but the best practice is to keep the radiator and air conditioning condenser fins cleaned from bugs, leaves and debris, which can block airflow and make the fan work extra harder as well. So, the engine cooling fan is a very vital, critical component, active component of your car's cooling system. While simple in concept, its failure can lead to a very serious and expensive engine damage from overheating. So understanding how it works and recognizing the sign of failure can save you from being stranded and facing a hefty repair bill. So always check the well-being of the blades, make sure that they are not broken. Check the blades, make sure that they are all in good shape, and make sure they are not broken as well. So this is a very simple inspection that you can do. Well, dear viewers, that is all we have for you regarding some of the things that you need to know about the cooling fan. It seems a very simple component, but it's a very critical component on your engine. If you find this video helpful and if you like what has been presented, please smash the like button. If you are new to this channel, do consider subscribing. Turn on notifications so that you will be the first to get notified whenever we come up with another video. Until then, stay safe.